March 25, 1938. A young man boards a steamship from Palermo to Naples. He carries a ticket, a suitcase, and a secret that would haunt physics for nearly a century. Within hours, he would disappear without a trace. No body. No explanation. Just darkness. And what makes this story truly terrifying is what he left behind. A discovery so powerful that some believe he vanished to protect humanity from itself. This is the story of the physicist who may have unlocked the door to infinite energy, then walked through it and never came back. Rome, 1926. The world is still reeling from the Great War, yet in the halls of science, a different revolution is brewing. Einstein has shattered our understanding of reality. Quantum mechanics is revealing that the universe operates on rules, so bizarre they seem like pure magic. In this golden age of physics, Italy produces a group of young scientists who will change everything. They call themselves the Via Panisperna Boys, named after the street where their institute sits in Rome. Leading them is Enrico Fermi, a man whose name will one day be synonymous with nuclear power. But among this brilliant group, there is one who stands apart. One whose mind operates on a level that even Fermi cannot fully comprehend. His name is Ettore Majorana. Born in Sicily in 1906, Majorana is not just intelligent. He is something else entirely. As a child, he could perform cubic roots in his head for entertainment. By his early 20s, he is solving problems that have stumped the greatest minds in physics. And unlike his colleagues who chase recognition and fame, Majorana views his own brilliance as boring. He solves impossible equations, then throws the papers away because once something is understood, he considers it trivial. This is not humility. This is a mind operating so far beyond normal that normal achievements feel meaningless to him. In 1932, something happens that reveals just how far ahead Majorana truly is. French physicists Irene and Frédéric Joliot-Curie detect a mysterious particle in their experiments. They think it might be a powerful gamma ray. The scientific community debates. Papers are written. Conferences are held. But Majorana sees the truth immediately. He explains to Fermi why this particle must be as heavy as a proton but electrically neutral. A neutron, the particle that would become the key to nuclear fission, the particle that would make atomic bombs possible. Fermi begs him to publish, to claim the discovery, to take his place in history. Majorana refuses. He does not bother. The credit goes to James Chadwick instead, who confirms it experimentally months later. But this moment is crucial, because it shows that Majorana could see the implications of nuclear physics before almost anyone else on Earth. And what he saw would haunt him. During this same period, Majorana is working on something that seems almost like science fiction. He is exploring the strange realm where matter meets antimatter, where particles can be their own opposites. In 1937, he publishes his final paper. It describes particles that are their own antiparticles, particles that exist on the boundary between existence and non-existence. He calls them Majorana fermions. The mathematics are so advanced that most physicists do not fully understand what he has done. Even today, over 8 decades later, scientists are still discovering the implications of his work. These particles, if they exist, could revolutionize quantum computing. They could unlock new forms of energy. They could change everything we know about the universe. And Majorana figured this out in the 1930s, working with paper and pencil, before computers, before particle accelerators, before any of the tools that modern physicists take for granted. Some theorists believe that Majorana particles might make up the missing mass of the universe, dark matter, the invisible substance that holds galaxies together. Others think they could be the key to unlimited clean energy, to quantum computers that could solve problems in seconds that would take traditional computers billions of years. But something is happening to Majorana during these years of breakthrough after breakthrough. He is changing, withdrawing. In 1933, he returns from Germany with acute gastritis and what his colleagues called nervous exhaustion. But perhaps it is something more. Perhaps he is seeing too far ahead. His mother notices it first. He becomes cold, distant. He stops coming to the institute. He rarely leaves his home. For nearly 4 years, the most brilliant physicist in Italy becomes a ghost, hidden away in his apartment, filling notebooks with calculations that no one else will see. His colleagues whisper. Some think he is going mad. Others believe he is working on something too dangerous to share. What we know now looking back is chilling. During these years of isolation, Major Rana is watching the world inch closer to nuclear weapons. He understands what others do not yet grasp. The neutron he helped identify could split atoms. Chain reactions could release unimaginable energy. Bombs 1,000,000 times more powerful than anything ever created. And he sees all of this before Los Alamos, before the Manhattan Project, before Hiroshima and Nagasaki prove him terrifyingly right. Then unexpectedly, in January 1938, Major Rana receives an honor, without even taking an examination. He is appointed to a full professorship of theoretical physics at the University of Naples. This is unprecedented. The Italian government recognizes his singular expertise. His colleagues celebrate. His family rejoices. But Major Rana seems haunted. He withdraws a large sum of money from his bank account. All of it. On March 23rd, he travels from Naples to Palermo by steamship. He writes a letter to Antonio Corelli, the director of the Naples Physics Institute. The letter is strange, cryptic. I have made a decision that has become unavoidable, he writes. There's not a bit of selfishness in it, but I realize what trouble my sudden disappearance will cause you and the students. He mentions keeping fond memories of them all at least until 11 p.m. tonight, possibly later too. What happens at 11 p.m.? No one knows. He leaves another note for his family. I have only one wish, he writes, that you do not wear black. If you want to bow to custom, wear some sign of mourning, but for no more than 3 days. On March 25th, Major Rana boards the steamship back to Naples. He is seen on deck. Witnesses will later report that he seemed calm, distant, lost in thought. Then he sends a telegram to Corelli that deepens the mystery. The sea has rejected me, it reads. I will be back tomorrow. Some colleagues claim they saw him return to Naples. A porter at the Hotel Bologna, where Major Rana had reserved his room, believes he recognizes him. But after that night, nothing. Ettore Major Rana, one of the greatest minds in the history of physics, vanishes without a trace. His body is never found. His room is still reserved. His money is gone, and his final calculations, left of the colleague days before his disappearance, mysteriously disappear in the chaos that follows. An incalculable loss, one historian will later say. Perhaps not even Ettore would have been able to calculate it. The disappearance sparks an immediate investigation. Enrico Fermi, his mentor, is devastated. He even goes to Benito Mussolini, Italy's fascist dictator, to request a nationwide search. During this meeting, Fermi says something extraordinary. There are several categories of scientists in the world, he tells Mussolini. Those of second or third rank do their best, but never get very far. Then there is the first rank, those who make important discoveries fundamental to scientific progress. But then there are the geniuses, like Galileo and Newton. Major Rana was one of these, a genius among geniuses. And Fermi adds something else, something that sends chills down the spines of those who hear it. Ettore was too intelligent. He says to his wife, if he has decided to disappear, no one will be able to find him. Think about that. A man so brilliant that if he chose to vanish, he could do so completely. No trace, no trail, just gone. The Italian police search. The Coast Guard investigates. Newspapers run stories. But there is nothing. Major Rana has performed the perfect disappearance. Over the following decades, theories multiply like particles in a collider. Some believe he committed suicide, that the weight of what he understood drove him into the sea. But the evidence does not fit. Why withdraw all his money if you plan to die? Why send a telegram saying the sea rejected you? Others suggest he fled to a monastery, that his Catholic faith led him to renounce the world and its terrible knowledge. There are reports of a monk matching his description, but nothing confirmed. Some theorize he escaped to Argentina or Venezuela, living under a different name, trying to forget what he knew. In 1955, a witness claims to have met a man called Bini in Venezuela, an Italian expatriate who seemed educated, troubled, always carrying papers filled with complex equations. In 2011, a photograph surfaces. Forensic analysis suggests it could be Majorana, aged but recognizable, alive 17 years after his disappearance. The Italian authorities investigate. They conclude he likely lived in Valencia, Venezuela, between 1955 and 1959 under the surname Vinny. But even this is not certain. The mystery refuses to be solved. And perhaps that is exactly what Majorana intended, because the most haunting theory is this: that Majorana did not disappear because of mental illness or faith or escape. He disappeared because of what he understood. The famous Italian writer Leonardo Sciascia became obsessed with this idea. He believed that Majorana foresaw the creation of nuclear weapons, that he understood the neutron, the chain reaction, the bombs that would incinerate entire cities, and that this knowledge, this terrible burden of seeing the future, drove him to remove himself from the world, to disappear so completely that he could never be forced to help build what he knew was coming. Think about the timeline. Majorana vanishes in March 1938. The discovery of nuclear fission happens in December 1938, just 9 months later. The Manhattan Project begins in 1942. Hiroshima is destroyed in August 1945. Everything Majorana might have feared came true. And if he truly understood the implications of his work with neutrons and nuclear forces, if he calculated ahead to where this knowledge would lead, then his disappearance becomes something different. Not an escape from life, but an escape from responsibility, a refusal to be part of the destruction that physics would unleash upon the world. J. Robert Oppenheimer, who led the Manhattan Project and watched the first atomic bomb test, would later quote ancient Hindu scripture, "Now I am become death, the destroyer of worlds." But Majorana never had to speak those words, because he was already gone. What makes this story even more incredible is what happened after he vanished. The particles he predicted, the Majorana fermions, were thought to be purely theoretical curiosities. For decades, no one could find them. No one even knew how to look for them. But in 2012, researchers at Delft University in the Netherlands detected the first solid evidence of their existence. Using superconducting nanowires and powerful magnetic fields, they created conditions where these exotic particles could emerge. The discovery sent shock waves through the physics community, because Majorana fermions are not just theoretical curiosities. They are revolutionary. These particles could be used to build quantum computers that are essentially immune to errors. Traditional quantum computers are incredibly fragile. The slightest disturbance destroys their calculations. But quantum computers based on Majorana fermions would be protected by the laws of topology itself. They would be stable, powerful, capable of calculations that seem like magic, and beyond computing. These particles might hold the key to new forms of energy generation. They might help us understand dark matter. They might even explain why neutrinos have mass, a question that still puzzles physicists today. In 2014, another team at Princeton captured a glowing image of a Majorana fermion perched at the end of an atomically thin wire, exactly where decades of calculations had predicted it should be. The calculations Majorana had done on paper in the 1930s, without computers or modern instruments, were being confirmed. His genius was being vindicated 76 years after he vanished. In 2025, Microsoft announced they had created a processor called Majorana 1 for quantum computing, using these exotic particles to build hardware-protected topological qubits. The technology that seemed impossible is now becoming real. And it all traces back to papers written by a man who then erased himself from existence. Some estimates suggest that quantum computers based on Majorana fermions could revolutionize everything from drug discovery to artificial intelligence to clean energy production. They could help us solve climate change, cure diseases, understand the universe in ways we cannot yet imagine. The technology that Majorana envisioned could give humanity near-infinite computational power, which in many ways is a form of infinite energy for the mind. But here is what keeps scientists awake at night. What else did Majorana calculate in those missing notebooks? What other discoveries did he make during his 4 years of isolation? The papers he left with his colleague before vanishing were lost, destroyed, or hidden. We will never know what they contained. Was there something even more dangerous than nuclear weapons? some discovery so profound that it had to be hidden. Majorana once said that everything that can be understood is banal. But what if he understood something that was not banal at all? What if he cracked open a door to knowledge so dangerous that the only responsible thing to do was to walk away, to disappear, to take that knowledge with him into the darkness? Today, physicists still search for answers. Research teams around the world are working with Majorana fermions, pushing toward the quantum revolution that his work made possible. But every breakthrough carries an echo of the question: what did he see that we still do not? Was Édouard Majorana a tragic genius driven mad by his own brilliance? A man of faith who chose spiritual contemplation over worldly achievement? A coward who fled his responsibilities? Or was he something else entirely? A man who calculated the cost of knowledge and found it too high, who saw that some doors should remain closed, some questions should stay unanswered, some power should never be claimed, who chose to remove himself from the equation rather than become the destroyer of worlds. We may never know the truth. The sea may have rejected him, as he cryptically wrote, but history has not. His name appears in cutting-edge research papers. His particles are being harnessed in quantum laboratories. His legacy grows with each passing year. And somewhere in the darkness of that unsolved mystery, there is a truth that we may never be ready to face. That the greatest act of genius is sometimes to know when to stop. That infinite power and infinite energy come with infinite responsibility. That some scientists advance humanity by their discoveries, while others save humanity by their silence. Édouard Majorana walked into the night of March 25, 1938, and never came back. But his shadow stretches across nearly a century of physics. Reminder that the most important discoveries are not always the ones we publish, but the ones we choose to leave hidden. If this story of vanished genius and hidden knowledge fascinated you, make sure you hit that like button and subscribe for more mysteries that change the world forever. Because the truth is always stranger than fiction, and some mysteries are meant to stay unsolved. The question is not always what we can discover, but what we should discover, and whether we have the wisdom to know the difference.